Welcome to the cosmic journey of the Sun, the radiant heart of our solar system. Join us as we explore the captivating tale of its birth, evolution, and ultimate destiny. But before we begin, don't forget to subscribe, ring the bell, and give a thumbs up. Formation. Approximately 4.6 billion years ago, a nebula composed mostly of hydrogen and helium gas along with trace amounts of other elements begins to collapse under its own gravity due to a disturbance like a nearby supernova explosion or a passing shockwave. As the nebula contracts, its gravitational energy is converted into heat energy, causing the core to heat up and pressure to increase. Eventually, the temperature and pressure at the core become so high that nuclear fusion reactions begin, primarily converting hydrogen into helium. This marks the birth of a star like our Sun. Main sequence. The main sequence phase, which lasts for about 90% of a star's lifetime, is estimated to span approximately 10 billion years. The Sun, having been in this phase for around 4.5 billion years already, is expected to continue in the main sequence for another 5 billion years. During this phase, the star is stable and generates energy through nuclear fusion in its core. In the case of the Sun, hydrogen nuclei fuse together to form helium nuclei, releasing tremendous amounts of energy in the process. This energy counteracts the force of gravity trying to collapse the star further, maintaining its equilibrium. The Sun's luminosity and temperature remain relatively stable during this phase. Red giant. In 5 billion years from now, the Sun will exhaust the hydrogen fuel in its core. As nuclear fusion slows down, the core will contract and heat up, while the outer layers expand. The expanding outer layers cause the Sun to swell into a red giant, increasing its size and luminosity. During this phase, the Sun's outer layers will engulf nearby planets like Mercury and Venus, although Earth's fate is uncertain. In the core of the red giant, helium fusion begins, converting helium into heavier elements. Helium burning. In the core of the red giant, the temperature and pressure continue to increase as helium fusion reactions occur, creating even heavier elements like carbon. These fusion reactions generate energy, which counteracts gravitational collapse and prevents further contraction of the core. Planetary nebula. As the red giant sheds its outer layers into space, it forms a glowing shell of gas and dust known as a planetary nebula. These nebulae can exhibit intricate and beautiful shapes as they are illuminated by the ultraviolet radiation from the dying star. The core that remains after the expulsion of the outer layers is a dense, hot stellar remnant known as a white dwarf. White dwarf. After approximately 6 billion years, the Sun will end up as a white dwarf. The white dwarf represents the final stage in the life of a Sun-like star, characterized by its extreme density, with half the mass of the Sun compressed into a volume roughly the size of Earth. Without nuclear fusion occurring in its core, the white dwarf gradually cools down over billions of years, eventually becoming a black dwarf. However, this cooling process takes much longer than the current age of the universe, so no black dwarfs are thought to exist yet. From birth to white dwarf, the Sun's journey illuminates the grandeur of cosmic evolution. Let its story inspire our quest for knowledge in the endless expanse of the universe. Don't miss out. Subscribe for more captivating content and give this video a thumbs up. Join us on our exploration of the cosmos.